Our goal in problem 1 is to find the antiderivative of the function, minus 6x squared, plus 9x times cosine of 4x. Our aim in this problem is to find the antiderivative of the function, minus 6x squared, plus 9x times cosine of 4x. Let us integrate the function, minus 6x squared, plus 9x times cosine of 4x. We know that, at first glance we easily see that the function we have to integrate is a product of a nonlinear function, cosine of 4x, with a polynomial function, minus 6x squared, plus 9x. Occasionally, when you are faced with this type of complex integration problem, you have to adopt the appropriate strategy that will help you simplify the problem, and find the antiderivative efficiently. The two main techniques that we learn in Calculus 2, for solving integrals that involve the products or quotients of nonlinear functions are the U substitution method and the method of integration by parts. The crucial first step of our strategy is to decide which of these two classical methods we should use. In this case, we have a product of a nonlinear function with a polynomial function, so the best method to use is the method of integration by parts. Because this method will help us reduce the complexity of the problem by reducing the degree of the polynomial. As a matter of fact, the polynomial function, minus 6x squared, plus 9x is of degree 2. In sum, our first goal will be to reduce the degree of the polynomial function to 1, by using the method of integration by parts. Let us briefly review the method of integration by parts. We know that the integral of u dv is equal to u times v, minus the integral of v du. It comes that, we set u equal to, minus 6x squared, plus 9x, so du equals, minus 12x, plus 9 dx. And, dv equals to cosine of 4x dx, and v equals to 1 over 4 times sine of 4x. Finally, the integral of, minus 6x squared, plus 9x times cosine of 4x dx is equal to, minus 6x squared, plus 9x over 4 times sine of 4x, plus the integral of 12x, minus 9 over 4 times sine of 4x dx. Consequently we still have to integrate 12x, minus 9 over 4 times sine of 4x, using integration by parts. Let us integrate the function 12x, minus 9 over 4 times sine of 4x. Given that the function to integrate 12x, minus 9 over 4 times sine of 4x is still the product of a nonlinear function with a polynomial function, we still have to use the method of integration by parts. The main aim of these repeated utilization of the method of integration by parts is to reduce the degree of the polynomial function 12x, minus 9 over 4. Therefore, we set u equal to 12x, minus 9 over 4, so du equals 3 dx. And, dv equals to sine of 4x dx, and v equals to, minus 1 over 4 times cosine of 4x. Eventually, the integral of 12x, minus 9 over 4 times sine of 4x dx is equal to, minus 12x, plus 9 over 16 times cosine of 4x, plus 3 over 16 times sine of 4x, plus a constant c. Now we have to aggregate the results of these repeated applications of the integration by parts to get the final value of the antiderivative of, minus 6x squared, plus 9x times cosine of 4x. The first integration by parts gave the following result. So, the integral of, minus 6x squared, plus 9x times cosine of 4x dx is equal to, minus 6x squared, plus 9x over 4 times sine of 4x, plus the integral of 3 over 4 times cosine of 4x dx. From the second integration by parts, we obtain the following result. So, the integral of 3 over 4 times cosine of 4x dx is equal to minus 12x, plus 9 over 16 times cosine of 4x, plus 3 over 16 times sine of 4x plus a constant of integration c. As a result, combining the last two results, we see that the integral of minus 6x squared plus 9x times cosine of 4x dx is equal to minus 6x squared plus 9x over 4 times sine of 4x plus minus 12x plus 9 over 16 times cosine of 4x plus 3 over 16 times sine of 4x plus a constant of integration c.